Hello and welcome to Science and Sleep. If you are here, perhaps you are looking for a truly gentle space where science is not dry but becomes a companion, helping you relax and easily drift into a deep sleep. Tonight, we will slowly and delicately embark on a journey to explore the mysteries hidden deep within the Earth, where volcanoes breathe, where magma stirs, and where our planet sometimes chooses to release itself with a sigh of smoke and ash. This is not only a story of science, but also a gentle voyage for you to both learn and unwind. If you find yourself smiling or gradually feeling your eyelids grow heavy, don't forget to hit subscribe and stay until the end of the video. Your presence is the very source of motivation for me to continue creating such fascinating journeys. When we speak of the hidden heart of the Earth, it is easy to imagine that it is nothing more than a massive rock lying silently in the universe. But the truth is far different. This planet is like a living body, with a heartbeat, with breath, and with sudden fits of anger. Volcanoes are the clearest proof of this. They are natural pressure valves where the Earth releases energy that has been trapped for millions of years beneath the surface. And if you listen closely, every roar, every stream of lava flowing down the mountainside is part of a story deeper and older than any civilization. To understand volcanoes, we need to start from the fragile crust we live on. If the Earth were an apple, the crust would be as thin as the apple's skin. Beneath that crust lies the mantle, a sea of dense rock, not entirely solid, not entirely liquid. It is like a giant syrup, slowly moving in the dark, accumulating heat and pressure over time. From this depth, magma, a mixture of molten rock and gas, is born. You can imagine magma as the Earth's simmering blood, always searching for an opportunity to rise to the surface. What is fascinating is that magma does not simply appear everywhere. It needs special conditions. When pressure drops rapidly enough, when temperature rises higher than usual, or when water seeps deep into fractures. When one of these three conditions occurs, rock begins to melt, forming magma. And because magma is lighter than the solid rock around it, it starts its journey upward, like bubbles of gas rising in a glass of mineral water. That journey can last hundreds of thousands of years, slow and patient, before producing the eruptions we often see at the surface. When magma finds a pathway, it accumulates in underground chambers called magma chambers. Imagine them as reservoirs beneath the earth, where millions of tons of molten rock silently gather, bearing the immense weight from above. Most of the time, they just remain there, quiet. But when the pressure exceeds the limits of endurance, or when a crack suddenly opens, the calm vanishes. Magma surges upward through natural conduits, exploding into lava, ash, gases, and sometimes even fierce lightning storms. Yet, no matter how loud, these eruptions are only the small visible tip of a process that has been quietly unfolding underground for millions of years. One of the things that makes volcanoes so captivating is the diversity of their forms and characters. Not all volcanoes are the same. Some are shield volcanoes, broad and gently sloping like enormous overturned bowls formed from lava flows that travel far and fast before cooling. A prime example is Mauna Loa in Hawaii, one of the largest volcanoes on Earth. It may not tower over other mountains, but its vast expanse makes it a true giant. In contrast are stratovolcanoes, tall, steep, and majestic, like icons on postcards. Mount Fuji in Japan or Mount Rainier in the United States belong to this type. They are formed from alternating layers of ash, rock fragments, and lava stacked over thousands of years, creating magnificent peaks but also concealing instability. An eruption from these volcanoes can turn the sky gray with ash and alter the local climate for months. There are also smaller volcanoes called cinder cone volcanoes. They often don't last long but are extremely active. Formed almost entirely from ash and debris that fall back around the vent, these volcanoes rise quickly and then fade over time. Yet, whether large or small, every volcano is a window into the secret world beneath our feet. If you're lying down and feeling your eyelids start to grow heavy, try imagining this planet as a giant stage. Volcanoes are the fireworks displays that remind us the Earth never truly sleeps. Beneath your feet, thousands of kilometers down, the mantle is still slowly moving, magma is still quietly searching for a way upward, and pressure is still building day by day. Every time the Earth breathes out through an eruption, it is not only a geological event, but also proof of the planet's vitality and ceaseless dynamism. Another fascinating truth is that volcanoes are not only destroyers, they are also creators. After each eruption, lava cools into new rock, expanding land, creating new islands in the ocean, or enriching soil with mineral rich ash. Because of this, lands around volcanoes, though dangerous, are often places where people choose to live and farm. So, when we speak of volcanoes, remember that this is not only a story of violence and destruction, it is also a story of rebirth, of the endless cycle between annihilation and creation. And within every layer of lava, every column of smoke, every rumble beneath the ground, there is an ancient melody, the background music the Earth has been playing for 4.5 billion years. When we talk about volcanoes, many people immediately think of violent explosions, clouds of ash rising, and glowing lava streaming down the mountainside. But in fact, hidden behind those dramatic moments is a long journey of magma, the molten substance that silently moves beneath our feet. What is fascinating is that not all magma is the same, and it is precisely the differences in chemical composition, temperature, and pressure that create the unique personalities of each eruption. Some flow gently like honey on pancakes, while others suddenly erupt in fury, like a soda bottle shaken too hard before being opened. To understand the story, we must begin with the most important factor, silica. This is the key component that determines the viscosity and the explosiveness of magma. When silica content is low, magma is fluid and flexible, allowing gases to escape easily, resulting in smooth lava flows that are less dangerous. But when silica is abundant, magma becomes thick and sticky, as if it were being held back, trapping gases inside. At some point, when the pressure is great enough, everything explodes in both impressive and dangerous ways. There are three main types of magma, each like a character with its own personality. Basaltic magma is the most easygoing, full of energy, but not demanding. With silica content of only about 45 to 55%, it easily flows to the surface, forming giant shield volcanoes like those in Hawaii. When you stand before a basaltic lava flow, you will see it resembling a glowing orange syrup, moving slowly yet steadily down a slope. These eruptions are usually gentle, lasting many days or even years, both beautiful and mesmerizing. In contrast to this calmness is rhyolitic magma, the true diva of the geological world. Containing over 65% silica, it is viscous, difficult to move, and compressed with a large amount of gas. When this magma finds a way out, it rarely does so quietly. Instead, rhyolitic eruptions can send tons of ash high into the sky, creating massive clouds and sometimes leaving behind craters that collapse into calderas. Fortunately, such eruptions are quite rare, but whenever they do occur, they leave deep marks in the history of the Earth. Between these two extremes lies andesitic magma, neither too gentle nor too extreme. This type of magma often forms stratovolcanoes, tall and steep, majestic in appearance but hiding great danger. When they erupt, they can produce scorching pyroclastic flows that sweep away everything in their path, or ash clouds that turn the sky gray. That is why many famous volcanoes, from the Andes to the Cascades, belong to this type. But the story does not stop at composition. Temperature and pressure also play important roles. Basaltic magma is usually the hottest, from 1000 to 1200 degrees Celsius, hot enough to melt anything in its way. Meanwhile, rhyolitic magma is cooler, only about 600 to 800 degrees Celsius, but precisely because it is viscous and gas rich, it is far more dangerous. You can imagine this difference like comparing a warm campfire to a firework suddenly exploding right before your eyes. As magma rises closer to the surface, pressure gradually decreases. The gases dissolved in magma, mainly water vapor, carbon dioxide, and sulfur dioxide, begin to separate into bubbles. If the magma is fluid, the bubbles escape easily, and we have a gentle eruption. But if the magma is thick and viscous, the bubbles get trapped, pressure builds up, and the result is a violent explosion. This phenomenon is not much different from opening a can of soda that has been shaken. As long as the lid stays closed, everything seems calm, but just one small crack and the pent-up energy is released instantly. Another fascinating part of the story is the magma chambers, where all the preparation takes place. Contrary to the image often seen in cartoons, magma chambers are not giant glowing pools of lava. In fact, they are more like regions of partially solid, partially molten rock, with complex networks of conduits where magma slowly accumulates and evolves. Over time, through a process called fractional crystallization, some minerals solidify, leaving the remaining magma richer in silica and gases. Sometimes different batches of magma even mix together, creating an unpredictable geological cocktail, and this mixing itself can spark an unexpected eruption. When a volcano actually erupts, it can take many forms. Some eruptions are gentle, called Hawaiian eruptions, where lava flows continuously, beautiful and hypnotic. Others erupt in bursts, like Strombolian eruptions in Italy, where glowing blobs of lava are thrown into the air before falling down the slopes. And then there are violent Plinian eruptions, like Vesuvius that buried Pompeii, shooting ash and rocks into the stratosphere and making an entire civilization tremble. What amazes us is that even though they sometimes destroy, volcanoes also bring life. Volcanic soils rich in minerals form the foundation for fertile agriculture. New islands like Hawaii are born from basaltic lava flows, and the gases released from eruptions over millions of years have helped shape the atmosphere, turning Earth into a habitable home. So, whenever you see the image of a glowing lava flow or a volcanic plume, remember that behind it lies not only violence, but also the silent heartbeat of our planet. Volcanoes are not only destruction, but also proof of the endless cycle destruction, renewal, and nourishment. And perhaps in the moment of looking at such scenes, we may find a strange relaxation, as if the earth is whispering an ancient story in the language of fire and stone. If we consider the earth as a giant living body, then volcanoes are its heartbeats, sometimes rapid, sometimes whispering, reminding us that this planet is still burning and full of energy within. When a volcano erupts, it is not just a simple geological event, but also a moment for us to witness the connection between the fragile surface we live on and the seething world hidden beneath. What is interesting is that not all eruptions are the same. Some volcanoes are gentle, as if merely exhaling smoke, slowly oozing glowing lava, flowing down the slopes like a luminous river in the dark night. But there are also volcanoes that erupt violently, creating massive ash columns that can reach the stratosphere, darken the sky in broad daylight, and leave consequences lasting for decades. Science calls this classification the VEI, Volcanic Explosivity Index, like a ruler measuring the degree of eruption from small whispers to explosions powerful enough to alter the planet's climate. Among these, some types of eruptions are very distinctive and tied to famous names. For example, Strombolian eruptions, named after an island in Italy, are moderate but extremely spectacular. Imagine jets of lava shooting into the sky like red-orange fireworks, illuminating the night. Not too dangerous, but mesmerizing enough to captivate tourists and scientists alike. A step higher are volcanian eruptions. They are more violent, involving viscous magma and great pressure. Short but powerful blasts can hurl ash, rocks, and create shock waves that travel far. The name of this eruption type comes from Volcano, another Italian island, associated with the legend of Vulcan, the Roman god of fire. Then there are Plinian eruptions, among the most infamous. They are named after Pliny the Younger, the Roman historian who witnessed the catastrophic eruption of Mount Vesuvius in 79 AD. That was the eruption that buried Pompeii under meters of ash, turning it into a geological time capsule. The hallmark of Plinian eruptions is the massive column of ash and gas rising tens of kilometers high, accompanied by volcanic lightning, deadly pyroclastic flows, and ashfall heavy enough to collapse roofs dozens of kilometers away. This is the kind of eruption that history and human memory still shudder to recall. And at an even rarer level, there are super eruptions. They do not occur often, perhaps once every tens of thousands of years, but whenever they do, they leave a mark on the entire planet. A super eruption can pump billions of tons of ash and sulfur gases into the atmosphere, blocking sunlight, cooling global temperatures for years, and even reshaping ecosystems. A prime example is the 1991 eruption of Mount Pinatubo in the Philippines, which caused global temperatures to drop by about half a degree Celsius for several years, a seemingly small number, but enough to affect crops and weather worldwide. But volcanoes are not just about lava and ash. They are also giant gas factories. Water vapor is the most common component, followed by carbon dioxide, sulfur dioxide, and hydrogen sulfide. Some of these gases are harmless at a distance, but under certain conditions, they can become deadly hazards. In 1986, in Cameroon, a sudden release of CO2 from Lake Nyos, which had been infused with volcanic gases from beneath, killed more than 1,700 people in a single night. No fire, no lava, just an invisible cloud sweeping through villages, taking lives without warning. If ash can travel far and disrupt aviation, as in the 2010 Eyjafjallajökull eruption in Iceland that shut down European airspace for days, then pyroclastic flows are the close-range threat. Imagine a massive avalanche, but instead of icy snow, it is a scorching mixture of superheated gases, ash, and rock fragments rushing down at hundreds of kilometers per hour. It does not only burn, but crushes and buries everything in its path. Pompeii and Saint Pierre on the island of Martinique in 1902 were both destroyed by such firestorms. However, not everything volcanoes create is tied to destruction. They also build and create. Lava, when cooled, becomes fertile soil, giving rise to rich farmlands that humans have cultivated for thousands of years. Many volcanic landscapes, from the black sand beaches of Hawaii to the deep blue crater lakes like Crater Lake in the United States, have become natural heritage sites, attracting millions of visitors each year. Lava domes, slow motion firework fountains, mysterious geysers at Yellowstone, all are evidence that this planet is more alive and creative than we imagine. Volcanoes can both whisper and roar. They tell the story of destruction and rebirth, of power and fragility. And most importantly, they remind us that the ground beneath our feet is not still, but is moving, melting, and reshaping, little by little over millions of years. Volcanoes, after all, are not just columns of smoke and streams of lava erupting to astonish humanity. They are the vivid diary of the planet, where each page is written in fire, ash, and profound climate changes. Every eruption, whether small or colossal, leaves a lasting mark on Earth's history and sometimes on human history as well. A striking example is the Toba eruption in Indonesia, which occurred about 74,000 years ago. At that time, an enormous amount of material, estimated at trillions of tons, was ejected into the sky, forming a dense layer of ash. It is imagined that if all that ash were gathered together, it could cover an entire large country. The consequence was a prolonged volcanic winter, when sunlight could barely penetrate the haze, causing global temperatures to plummet. Some scientists once hypothesized that this event nearly drove humanity to extinction, leaving only a small group to survive and continue evolving. Although this hypothesis remains debated, the fact is that this eruption carved a fierce chapter into Earth's history, a reminder that just one outburst from the depths is enough to alter the destiny of the entire biosphere. But volcanoes are not always destructive. Sometimes they sow the seeds of life in unexpected ways. Deep-sea hydrothermal vents, the so-called ecosystems of darkness, function completely independent of sunlight. Their icy seawater seeps into cracks, is heated by magma, then bursts back out with minerals. In this seemingly deadly environment, strange creatures still thrive. Tube worms, meters long, giant clams, bacteria that feed on sulfur instead of light. Many scientists believe that such places may have been the cradle of life billions of years ago. If that is true, then perhaps we, humans, trees, animals, all carry within us a fragment of the volcano's hot blood. Human civilization has also been repeatedly imprinted in volcanic history. Around 1600 BC, the eruption of Santorini in Greece wiped out much of the island, creating the famous crescent-shaped bay we see today. That immense power caused tsunamis, buried the Minoan civilization, and perhaps even inspired the legend of Atlantis. It is fascinating to see how a geological phenomenon can weave an entire myth, at once a disaster and a source of human imagination. Further back in history, we recall Vesuvius in 79 AD, the eruption that buried the city of Pompeii. The thick ash not only destroyed life at the time, but also accidentally became a time machine, preserving walls, streets, and even the shapes of people in their final moments. Thanks to that, later generations can witness Roman life in haunting detail. A unique proof that sometimes nature's destruction is also an act of memory keeping. Earth, through the hand of volcanoes, does not only take, it also gives back. As lava cools and ash blends into the soil, fertile lands are born. Volcanic slopes become havens for coffee, grapes, bananas, and countless crops. Some of the world's most renowned wines owe their distinct flavors to minerals in volcanic soil. And we cannot overlook the unique beauty of black sand beaches. Fine sand sparkling like graphite, making you feel as if you're standing on a surreal painting where sea meets fire and stone. Volcanoes in this way seem always to sustain a rhythm of balance between destruction and creation. Each eruption is like a reminder that our planet is not silent but alive, breathing, endlessly regenerating. If we are patient enough to observe, we will see a cycle from ash to fertile soil, from cooled stone to green forests, from temporary devastation to thriving life. And perhaps the most captivating thing about volcanoes is not just their grandeur or immense power, but the way they tell the story of time. An eruption may last only a few hours, but its consequences and traces endure for thousands, even millions of years. They compel us to view the world through a timescale far beyond a human lifetime, where tens of thousands of years are just a blink, and a new island rising from the sea is but a small step in Earth's endless journey. So, whether you are quietly listening to these lines to relax or imagining yourself walking along a field of cooled lava, remember that beneath our feet, the planet is still writing its story. A story sometimes loud with plumes of smoke, sometimes silent in tectonic processes, but always moving, always creating. And perhaps, at some moment in the future, you yourself will stand before a volcanic crater, not to fear, but to marvel, and to silently thank this fiery, yet profoundly generous planet. If the eruption of St. Helens opened a new era of volcano monitoring with modern science, it also reminds us that no technology can turn nature into a completely predictable entity. Each volcano has its own character, its own rhythm, and a secret part that humans can only gradually piece together through traces. This makes studying volcanoes feel like reading a colossal novel in which many chapters have been blurred by time, leaving only fragments for the reader to interpret. St. Helens, Vesuvius, Tambora, or Krakatoa are not just natural tragedies, they are milestones marking humanity's growing understanding of this planet. In every eruption, we see not only lava or ash, but also the intertwining of nature and human destiny. From the busy Romans in Pompeii to the Indonesian farmers who lost their harvests during the year without a summer, to the painters and writers who unexpectedly found inspiration in the glowing red skies after Krakatoa, volcanoes have touched culture, art, and collective memory more than we might think. And if you believe the story stops in the past, remember that our planet still has more than 1,500 active volcanoes. Each year, dozens of them erupt, sometimes quietly, sometimes violently. Consider the volcanoes in Iceland, where glowing red lava meets white snow, creating a scene both primordial and modern, watched worldwide through live broadcasts. In Hawaii, Kilauea erupted continuously for 35 years, quietly but persistently, leaving lava flows cutting across the ocean and expanding the island's territory meter by meter. These were not sudden events like Vesuvius, but rather powerful evidence that Earth is always in the process of rewriting its own map. It is fascinating to realize that many volcanoes are named with words evoking life rather than destruction. Hawaiians see Pele, the goddess of fire and volcanoes, as a symbol of creation, both fierce and nurturing. For them, lava not only destroys, but also gives birth. Within layers of ash, the land becomes fertile, greenery springs up quickly, and ecosystems of astonishing richness emerge. In this way, volcanoes resemble sculptors both stern and generous, one hand erasing, the other hand creating. But to understand more deeply, scientists today do not just observe the surface. They listen to the heartbeat of volcanoes through seismic tremors, measure gases escaping from vents, and monitor the swelling of the ground with satellites. Remote sensing technology and modern sensors transform geological ripples into readable data. From this, we can partly forecast the planet's next awakenings. Yet absolute accuracy remains out of reach. Volcanoes are like unpredictable artists, preparing their performance for months, only to erupt suddenly in a single afternoon. If you pause to think, you will see that no civilization escapes their influence. From the vineyards on fertile volcanic soil in Italy, to the newly formed islands in the Pacific, to the oxygen-rich atmosphere we breathe, all bear the marks of volcanoes. Without them, oceans might never have existed, the climate might never have stabilized, and life might never have flourished as it has. In many ways, volcanoes are both hazards and the primordial parents of life on Earth. From a broader perspective, scientists also use volcanoes as windows to understand other planets. The colossal volcanoes on Mars, such as Olympus Mons, 3 times taller than Everest, or the icy eruptions on Europa, suggest that volcanic activity is not just Earth's story, but a universal law in the cosmos. Perhaps, on some distant world, eruptions are also shaping landscapes and opening possibilities for life. When we watch lava flowing in Hawaii or smoke rising in Iceland, we are not only seeing Earth, but also glimpses of the universe itself. What makes volcanoes so captivating is their duality, both destructive and regenerative, terrifying and beautiful. An eruption can wipe out a city, yet also inspire an immortal artwork. It can take thousands of lives, yet nurture millions more afterward. In this sense, volcanoes are among the most powerful metaphors for existence itself, death and life, loss and hope, all present together in an eternal cycle. Therefore, when we recount the history of volcanoes, it is not just a list of geological events. It is a symphony spanning billions of years where Earth sings through the roar of magma, through the rhythm of eruptions. And we, the small creatures on this planet's surface, are both reluctant spectators and eager students, listening and recording this melody in our own way. When we talk about volcanoes, we often imagine giant columns of smoke, glowing red rivers of lava, and destruction spreading across the land. But perhaps what few expect is that these mountains are also sowers of life, mysterious artisans of nature, both destructive and creative. They are like unpredictable companions, sometimes erupting in fierce anger, but then gifting us with astonishingly abundant treasures. And it is this very contradiction that makes volcanoes an inseparable part of the story of the Earth and of humanity. Imagine this. You are standing at the foot of Mount Vesuvius in Italy. This was the volcano that wiped out the city of Pompeii in a fateful day in 79 AD, burying an entire civilization under ash. Yet paradoxically, the land surrounding it became one of the most fertile agricultural regions in Europe. Volcanic soil, after hundreds of years of decomposition, turned into nutrient-rich andesol, nurturing vineyards, tomato fields, and resilient olive trees. If you've ever enjoyed a glass of Etna wine or tasted a slice of Neapolitan pizza with San Marzano tomatoes, then you have savored the legacy of a volcano. Destruction in an instant, yet life-giving for centuries. Volcanoes embody a contradiction so profound that even poetry must bow to it. Not only soil, volcanoes also gift us with energy. In Iceland, a place perched between two diverging tectonic plates, people have learned to borrow heat from the earth. The geothermal system here provides electricity, hot water, and even keeps streets from freezing during winter. Steam rising from the ground, once thought by ancient people to be the breath of gods, has now become the world's cleanest, lowest emission energy solution. It's hard to believe that a land full of volcanoes has become a model for a sustainable future. And if you've ever soaked in a turquoise hot spring in Iceland or in a Japanese onsen, you have felt the gentle touch of volcanic energy, like being embraced by the Earth's primordial warmth. Yet volcanoes do not exist only in our material lives. They are imprinted in culture, faith, and the human spirit. In Hawaii, Pele, the goddess of volcanoes, is both the creator of new land and the destroyer of villages with just a single lava flow. People worship her, tell stories of her, and live with the breath of volcanoes as if with a family member. In Japan, sacred volcanic peaks like Mount Fuji are not only geographic icons, but also sources of inspiration for art, poetry, and religion. Volcanoes, therefore, are not merely heavy rocks. They are living beings in the collective imagination, bridges between humans and forces beyond control. However, to live alongside volcanoes, humans must learn to listen. Today, scientists not only observe smoke and roars, but also track tiny tremors underground, the swelling of the surface, or subtle changes in gases released from craters. Each signal is a piece of a puzzle, and when assembled, they can sketch the picture of an imminent eruption. In Japan, nationwide warning systems help people evacuate in time. In Italy, Vesuvius is monitored by the world's oldest observatory. And everywhere, scientists work tirelessly, knowing that 1 hour of accurate forecasting can save tens of thousands of lives. Volcanoes, in the end, are strict teachers, teaching us humility and preparedness. Interestingly, even with constant risk, people keep returning to volcanoes. Perhaps it's for the fertile soil, perhaps for the hot springs, or perhaps for the strange allure of landscapes both majestic and fragile. Black sand beaches, lava fields draped in moss, towering cliffs all evoke an extraordinary beauty, as if from another planet, or like secret chapters of Earth's history revealed to those daring enough to come close. And there is one more thing. Volcanoes remind us that this planet is still alive. Beneath the thin crust, Earth is always vibrant, always moving, always renewing. Every eruption, big or small, is a heartbeat of the planet. And when we gaze at a sky glowing red with ash, or step on new ground still warm from lava, we are not only witnessing raw power, but also sensing our own connection to this cosmic home. Volcanoes, in a way, make us realize that we are not separate from nature. We are part of it. Perhaps that is why people remain, planting crops, building homes, and singing songs in the shadow of these heaving mountains. Not because we forget the danger, but because we have learned to respect, to adapt, and even to be grateful. Volcanoes, in the end, tell not only a story of fire and stone, but also a story of courage, wisdom, and the human desire to endure. Um, when it comes to predicting volcanoes, we do not only step into a world of rigorous science, but also touch the fragile boundary between human intuition and the power of nature. Even with increasingly modern tools, from ultra-sensitive seismographs to sophisticated satellite radar, there is still one factor that makes everything unpredictable: the fickle temperament of the Earth itself. A volcano can accumulate energy for many years, even centuries, then suddenly awaken in just a few short days. Conversely, sometimes all the alarming warning signals, the swelling ground, the sharp rise in sulfur emissions, the flurry of earthquakes, end in prolonged silence, as if the mountain only wanted to tease the scientists. It is this uncertainty that has turned volcanology into a global detective game. Volcanologists must piece together clues from the four main languages the Earth often whispers in: seismicity, deformation, gas emissions, and temperature. They are like classical music listeners trying to distinguish each note in a vast symphony, where the cello of magma, the rhythmic beat of earthquakes, and the faint whisper of steam all blend together. And the astonishing thing is that sometimes, just a very small change, a millimeter shift on a GPS or an unusual spike in sulfur dioxide, can become the key to saving tens of thousands of lives. However, science is only half of the story. The other half is humanity. Volcanoes do not exist in empty space. They stand tall right next to villages, cities, and entire communities that have lived on the land for generations. This is where the story becomes complicated, because even when there are clear warnings, people often choose to stay. Part of it is economic: fertile soil, vibrant tourism, and livelihood opportunities. Another part comes from psychology: memory, familiarity, the belief that it won't happen to me. And sometimes it is a mixture of all those things. Imagine this: you were born on the slope of a volcano, where fertile land allows crops to flourish year round. Your home, your family, your childhood memories, everything is tied to this land. Then one day, the authorities issue an evacuation order warning that magma may erupt within weeks. Where will you go? What will you take with you? And do you truly believe that danger is approaching? Or is it just an overreaction from cold, unfeeling instruments? This is exactly the dilemma that millions of people around the world are facing. One of the classic examples is the eruption of Nevado del Ruiz in Colombia in 1985. Before the tragedy, scientists had warned about the possibility of lahars, deadly mixtures of melted ice, ash, and lava. Yet many residents of the town of Armero stayed behind, partly because information was not fully conveyed, partly because of the mindset of, it probably won't be that bad. When the volcano finally erupted, the mud flow swept away the entire town, killing more than 20,000 people in just a few hours. That tragedy was etched not only in the history of volcanology, but also as a grim reminder of the value of heeding warnings. Since such events, the scientific community and governments have focused more heavily on monitoring systems and risk communication. Today, many countries have 24/7 observation networks that transmit data directly to analysis centers. Alert levels are clearly categorized: green for normal conditions, yellow for unrest, orange for increased activity, and red for imminent eruption. But as mentioned, the issue is not whether warnings exist, but whether communities act on them. And this is the most human part of volcanology: connecting with people. Researchers do not just sit in front of screens analyzing data, they must also go down to villages, talk with residents, and explain why a small earthquake might be a sign of a major disaster. They must learn to communicate not just in academic language, but in stories that are simple, relatable, and persuasive. Because when people have to choose between the advice of a distant expert and the inherited wisdom of their ancestors, many still choose to trust family memory. This raises an intriguing question. Why are humans drawn to and willing to live next to volcanoes despite the danger? Part of the answer lies in economics, as mentioned, tourism, farmland, geothermal resources. But there is also something deeper, tied to psychology and culture. Volcanoes, with their majestic form and explosive power, are like symbols of might and mystery. Many communities regard them as deities, as protectors both revered and feared. To live near a volcano, in a sense, is to live in the constant presence of nature at its wildest. Some describe the feeling as keeping a tiger as a roommate. You admire its beauty and power, respect its boundaries, and are always aware that danger could strike at any moment. Yet it is precisely this tension that creates a peculiar kind of allure, a rhythm of life intertwined with the earth, where humans are no longer conquerors but companions. Ultimately, no matter how advanced science becomes, one truth remains unchanged. Volcanoes are vivid proof that the earth is still breathing, still moving beneath our feet. They remind us that nothing is truly permanent, that everything solid can change in an instant. And perhaps it is this very uncertainty that makes life around volcanoes both a profound challenge and a deeply meaningful experience. You can imagine, beneath that vast expanse of salty water, an entire world is silently and ceaselessly at work. We often think of the ocean as a tranquil blue space where creatures swim freely. But if the watery veil could be lifted, you would see a spectacular landscape, enormous mountain ranges, jagged rifts, and countless volcanoes quietly shaping the earth in ways the naked eye can never perceive. The seafloor, in fact, is a giant natural laboratory where magma, water, minerals, and life continuously interact. Underwater volcanoes are not merely the submerged versions of those on land. They are the engines that build the Earth's crust. When tectonic plates pull apart, magma rises from within the planet and cools, forming new rock. Imagine the seafloor growing by a few centimeters each year. A small number, but accumulated over millions of years, it creates mountain ranges longer than the Himalayas. The Mid-Atlantic Ridge is one example, stretching from the Arctic all the way to near the tip of Africa, running like the backbone of the Atlantic Ocean. If the seas could be drained, you would see a towering mountain range even more majestic than those we know on land. Interestingly, not all undersea eruptions happen silently. Sometimes the pressure and energy released are so immense that ash, gas bubbles, and pumice are hurled through the water column, floating across the sea surface like giant drifting carpets. Sailors once described the feeling of passing through a sea of floating stone, as if their ship were gliding through a surreal dream. At times, such eruptions are powerful enough to build an entirely new island in just a few weeks. Over time, these newborn islands become havens for seabirds, corals, and sometimes even people. But perhaps the most captivating story lies not in the lava itself, but in life. In places where sunlight can never reach, where the pressure could crush a submarine, entire communities thrive thanks to volcanic energy. Hydrothermal vents, those underwater black smokers, spew out superheated streams rich in minerals. With temperatures exceeding 350 degrees Celsius, these vents should be death traps. Yet here, giant tube worms, shrimp, crabs, clams, and countless other strange species flourish. They rely on symbiotic bacteria, organisms capable of transforming toxic chemicals like hydrogen sulfide into energy. This is a form of chemosynthesis, similar to photosynthesis but without the sun. Some scientists believe that these natural reactors may have been the cradle of life itself. The idea that our earliest ancestors were not land-dwelling beings but tiny bacteria clinging to undersea volcanic vents sounds both humble and powerful. It reminds us that life can arise and endure in the harshest of conditions. And if it can happen here, why not in the hidden oceans of Europa, Jupiter's moon, or Enceladus, Saturn's icy moon? Submarine volcanoes tell not only Earth's story, but also open the door to the possibility of extraterrestrial life. Beyond that, the activity of underwater volcanoes quietly shapes the global climate. When magma meets seawater, trace elements and dissolved gases are released, altering the ocean's chemical composition. Over the long term, these processes contribute to the carbon cycle, helping balance CO2 in the atmosphere. In other words, submarine eruptions can indirectly shape the very air we breathe each day. Of course, studying these sunken giants is anything but easy. At depths of thousands of meters, where sunlight vanishes completely, everything lies in darkness and the pressure is enough to crush steel. Scientists must rely on specialized machines, ROVs, remotely operated vehicles, and AUVs, autonomous underwater vehicles. Equipped with cameras, sensors, and robotic arms, they collect samples. Every frame of footage from the deep sea you might see on screen is the result of countless hours of risky operation and advanced engineering. Thanks to these tools, hundreds of previously unknown underwater volcanoes have been discovered. Yet in truth, what we have seen is only a small corner of the iceberg. It is estimated that more than 1 million submarine volcanoes exist across the oceans, most still unexplored. This makes the ocean the final frontier of science on Earth, a vast, mysterious world still waiting for us to listen. And perhaps that is the gentlest message of all. This planet is still whispering to us. Every lava flow, every hydrothermal vent, every submerged mountain in the dark tells a story of formation, of life, and of connection. When we press our ears to the ground or lower our cameras into the deep, we are not merely gathering data. We are learning how to listen to the earth, and from that, how to live more harmoniously with it. If Earth has amazed us with volcanoes hidden beneath the deep sea, then once we leave the blue planet, a whole universe of strange volcanoes awaits us. Volcanic activity is not just Earth's specialty. It is a universal language, written in fire, ice, and the invisible gravitational forces between celestial bodies. And to understand them, imagine that every planet and moon in the solar system is writing its own story through eruptions, flows, and faint plumes of smoke rising into the cold void of space. First, let's return for a moment to the moon, our familiar companion in the night sky. Today it seems quiet, covered in gray dust and impact craters, but in reality, billions of years ago, the moon once boiled like a giant forge. The dark patches, called lunar maria, visible even to the naked eye, are remnants of ancient lava when the crust cracked open and magma flooded the craters. The moon has fallen asleep, but its scarred surface still whispers of a fiery past, as if it remembers the days when it was still hot and youthful. If the moon is a lantern whose flame has gone out, then Io, Jupiter's moon, is a firework bursting endlessly. Io is considered the most volcanically active world in the entire solar system. Picture a surface glowing with shades of yellow, orange, red, and green, like a surreal painting drawn by the hand of an alien artist. On it, hundreds of volcanoes are quietly active, some erupting so violently that they hurl sulfur hundreds of kilometers into space. This power does not come from a hot core like Earth's, but from the immense gravitational pull of Jupiter and its neighboring moons. Io is like a marble being kneaded, bent, and stretched until it heats up and cracks, releasing energy in colossal eruptions. If you were to stand on Io, assuming you could survive its extreme conditions, you would see massive Jupiter looming overhead, while beneath your feet, columns of lava shoot upward like cosmic fireworks, a scene both breathtakingly beautiful and dangerously untouchable. Leaving Io, we arrive at Venus, Earth's sister planet. Shrouded in thick clouds and an atmosphere 90 times denser than Earth's, Venus is a scorching world where temperatures are hot enough to melt lead. Yet hidden beneath that veil of clouds lies a treasure trove of volcanoes. Hundreds of thousands of volcanic structures of various shapes, from massive shield volcanoes to bizarre pancake domes. Some recent evidence even suggests Venus has not died at all. Probe radar has recorded small surface changes, hinting that eruptions may still be occurring. If this is true, Venus is not only the hottest planet, but also a gigantic volcano still breathing, silently yet powerfully. From there, we move on to Mars, the red planet, home to Olympus Mons, the largest volcano in the solar system. Nearly 22 kilometers high and so wide that if you stood on its slope, you might not even realize you were climbing, since its gentle incline stretches hundreds of kilometers. The reason Olympus Mons reached such colossal size is that Mars lacks shifting tectonic plates like Earth's. This allowed a hot spot to keep feeding lava in the same place for millions of years, gradually building a mountain so immense it defies human imagination. Olympus Mons stands as an unmoving monument, both a testament to volcanic power and a reminder that the cosmos can create wonders beyond any scale we are used to. But not all volcanoes in the universe spew fire and molten rock. In icy worlds like Enceladus, a moon of Saturn, or Triton, a moon of Neptune, volcanoes breathe ice and water vapor instead. This phenomenon is called cryovolcanism, ice volcanoes. At Enceladus's south pole, the tiger stripes fissures continuously eject salty water and icy particles into space. The Cassini spacecraft once flew through these plumes and discovered organic molecules, the basic building blocks of life. This makes Enceladus one of the most promising candidates in the search for life beyond Earth. Triton 2, with nitrogen geysers erupting kilometers high, shows that even a distant or frozen moon can become a stage for the strange dance of ice volcanoes. What is astonishing is that, despite differences in form, size, and eruptive material, these volcanoes share a common mission. They shape surfaces, renew crusts, alter climates, and sometimes open doors to the possibility of life. From fiery eruptions on Io to toxic fumes on Venus to icy plumes on Enceladus, the universe whispers to us that volcanoes are not only about destruction, but also about beginnings. Each volcano is a story of power, of change, and of the life cycles of worlds. And next time you look up at the night sky at the quiet silver moon or the faint red dot of Mars, remember that behind those lights lies a whole world of volcanic activity, both familiar and strange. We have only just begun to listen to that story, but surely much more awaits discovery. When we mention a volcanic eruption, we often picture gigantic columns of ash rising high, rivers of glowing red lava flowing down the slopes, or small towns lying within the danger zone. But in fact, volcanoes are not only spectacular geological phenomena happening on the surface. Their impacts sometimes reach far beyond the disaster site and can even touch the atmosphere, the oceans, and even the global climate. The geological and climatic history of the Earth is tightly linked to those violent sighs of the planet. Each eruption is a reminder that our Earth is never silent, but always moving, transforming, and finding its own ways to shape the world humans live in. What's fascinating is that the effects of volcanoes are not always visible to the naked eye. A lava flow can destroy a forest or a village nearby, but it is the invisible gas molecules released during an eruption that truly carry global power. Take sulfur dioxide as an example. When it rises high enough, this gas reacts with water vapor and forms tiny droplets of sulfuric acid floating in the stratosphere. Under sunlight, these particles become a hazy mirror reflecting light back into space. The result is that the Earth's temperature drops, somewhat like when you open an umbrella under the summer sun, except this time the umbrella covers the entire planet. This is why a major eruption can sometimes bring unusually cool years, crop failures, and disrupted weather patterns. The case of Mount Tambora in 1815 is the clearest example. The eruption was so powerful that it hurled tens of cubic kilometers of ash into the atmosphere. As a result, the following year entered history as the year without a summer. In Europe, snow fell in June, cold rains persisted, and famine spread. In the United States, frost swept across crops, and grain prices rose so high that many families had no choice but to eat sparingly. And strangely enough, those gloomy months created the conditions for Mary Shelley to write the novel Frankenstein. A classic work was born from the coincidence between natural disaster and human imagination. Volcanoes, in a very indirect way, left their mark on human cultural history. A century later, Krakatoa proved again that the power of volcanoes can cross oceans and touch every corner of the sky. For many years, blood-red sunsets around the globe were paintings created by volcanic ash circling the Earth. People at the time called them strange skies, while painters captured them in their works with fiery tones. An eruption on a tiny island, yet it left memories in the collective mind of the world. Closer to our time was the 1991 Pinatubo eruption. This time, thanks to satellites and atmospheric monitoring stations, scientists tracked in detail how sulfur dioxide formed a sunlight-blocking veil. The Earth's average temperature dropped by about half a degree for several years, and the global climate model shifted noticeably. Monsoon winds moved, some regions became drier, while others received more rain. It was clear evidence that volcanoes are not just local disasters, but powerful temporary climate regulators. Yet, not every eruption brings cooling effects. On geological timescales, massive eruptions lasting thousands of years, like the Siberian traps or the Deccan traps, released enormous amounts of carbon dioxide. This greenhouse gas traps heat instead of reflecting it. Rather than cooling, it warmed the planet for millions of years, enough to contribute to mass extinction events. Once again, volcanoes can either be a cooling hand or a blanket of heat over the Earth, depending on time and scale. Beyond the atmosphere, volcanoes also influence the oceans. When ash and minerals fall into the sea, they alter the chemistry of the water, supplying iron and nutrients essential for phytoplankton blooms. These tiny organisms act like the green lungs of the planet, absorbing carbon dioxide and releasing oxygen. An eruption, in an unexpected way, can spark a burst of microscopic life in the ocean and affect the global carbon cycle. In fact, recent studies suggest that large eruptions may even alter the patterns of El Nino and La Nina. Just a small shift in the temperature difference across the Pacific Ocean can change the entire system of monsoons and storms on Earth. From Asian rice paddies to Atlantic hurricanes, everything is affected. Our world is more interconnected than we think, and a strong breath from the depths of the Earth in one place can become a shifting wind of seasons somewhere else. All of this shows that volcanoes are not just a story of geology. They are part of the heartbeat of the Earth, shaping climate, culture, ecosystems, and even human history. To understand volcanoes is to understand part of the planet's mechanisms, and to realize that we live on a world far more dynamic than its calm appearance suggests. And perhaps the next time you watch an unusually fiery sunset or read a classic novel born from a cold summer, remember that somewhere, deep within the earth, a volcano helped create that moment. Volcanoes, in all their contradictions and ferocity, are both destroyers and creators. To sense this, we can begin with an image that seems utterly still: a newly cooled basalt plain, dark, cold, and almost lifeless. But with patience, you will see time begin its work. Winds bring dust, spores, and tiny seeds of life. The first bacteria take root, then mosses, lichens, and other pioneering plants. Step by step, life creeps in, slowly transforming a harsh field of rock into fertile land. In ecology, this process is called primary succession, a testament that after every devastation, Earth always carries within itself the ability to regenerate. A vivid example of this phenomenon is Surtsey Island off the coast of Iceland, which emerged after an undersea eruption in 1963. At first, it was nothing but a bare mass of land, completely devoid of life. Yet over the decades, scientists have witnessed a whole symphony of evolution: mosses greening the land, migratory birds nesting, insects appearing, and now it has become a living ecological laboratory. What makes Surtsey special is that it has been preserved almost untouched, with no direct human interference, allowing us to witness a miniature Earth in the process of healing and creation. On a larger scale, the Hawaiian Islands are a majestic epic about the power of volcanoes. From a fixed magma hotspot beneath the ocean floor, as the tectonic plate drifts, new islands are born one by one. The Big Island, with Kilauea and Mauna Loa, is still erupting, creating entirely new land, while older islands are gradually worn down by wind, rain, and waves. Standing in Hawaii, you can walk through millions of years of geology in just a few steps. From young lava fields to lush rainforests shaped over thousands of years. This is a wonderful lesson in Earth's cycle of renewal. Nothing is permanent, yet life always finds a way back. Beyond creating land, volcanoes also leave behind an important legacy: fertile soil. As lava weathers, it releases valuable minerals such as iron, magnesium, potassium, and calcium. These nutrients form an ideal foundation for agriculture. That is why many of the world's most fertile and densely populated regions lie near volcanoes. The lush terraced fields around Mount Merapi in Indonesia, the famous vineyards at the foot of Mount Etna, or the coffee plantations on the slopes of Kilimanjaro. From death and ashes, new life not only sprouts but also sustains human civilization itself. But volcanoes do not only build land. Beneath the ocean's hydrothermal vents, where magma heats seawater seeping through the crust, have become some of the planet's most unique habitats. In the dark depths, where sunlight never reaches, strange creatures such as giant tube worms, clams, shrimp, and countless bacteria thrive. Instead of photosynthesis, they rely on chemosynthesis, transforming inorganic compounds into energy. Some scientists even believe that these hydrothermal systems may have been the cradle of the very first life on Earth, not from the sunlit ocean surface, but from within the darkness, where rock and water meet under primal heat. Volcanoes also play an important role in Earth's long-term climate cycle. While major eruptions can temporarily cool the climate by blocking sunlight, in the long run, the carbon dioxide they release contributes to regulating global temperatures. This is a delicate balance. Without volcanoes, Earth might have become a frozen, ice-covered world. But if they erupted too much, the planet would be too hot to sustain life. In the grand climate symphony, spanning millions of years, volcanoes are both conductor and musician, keeping Earth's melody from falling out of rhythm. And then, beyond destruction and survival, volcanoes also leave behind a spiritual gift: beauty. The fiery sunsets after eruptions once moved artists like J.M.W. Turner and Edvard Munch, inspiring them to capture those visions in their paintings. Skies painted with surreal shades of orange, purple, and red remind us that from ash and chaos can arise beauty beyond compare. Even in destruction, nature whispers about its eternity and its cycles. Ultimately, volcanoes are the perfect symbol of the dual nature of life on Earth: destruction and renewal, danger and fertility, chaos and order. They compel us to be humble before the planet's power, while also sparking hope that even after great upheavals, life always finds its way back. One could say that with every eruption, Earth is not only breathing, but also writing a new chapter of itself, a chapter both fierce and full of promise. Imagine you are standing on a volcano that has long been extinct. Before your eyes, a dark lava field stretches out like a rugged carpet, where once torrents of fiery red flowed down from the crater. Now that layer of rock has cooled, cracked into solid blocks, and in each tiny fissure, life has begun to take root again. A patch of green moss, a wild purple flower, or simply a fragile streak of grass, all are proof of the Earth's miraculous ability to regenerate. A volcano, in its fierce destruction, also opens the door to a new beginning. Delving deeper into the Earth, we step into the world of magma, a molten mixture of minerals, glowing and constantly moving. Magma is the silent heartbeat of this planet. It circulates, rises, and falls, creating small tremors, vibrations too faint for the human ear, but detectable through science. Wherever magma finds an escape, there a volcano is born. Yet not every eruption brings only devastation. Volcanic ash, when it falls, transforms into fertile soil, nourishing fields and forests for centuries to come. Think of the vineyards of Italy or the coffee fields of Hawaii. All exist thanks to the mineral-rich ash left behind by volcanoes. Perhaps that is why, since ancient times, humans have both feared and revered volcanoes. In Greek mythology, volcanoes were seen as the forge of the gods, where Hephaestus crafted weapons for Zeus. In Japan, Mount Fuji is not only a natural icon, but also a sacred mountain tied to spiritual rituals. In Hawaii, people believe that the goddess Pele lives within the crater, embodying both creation and destruction. These stories reveal that across all cultures, volcanoes are perceived as entities that go beyond pure science. They are bound to emotions, beliefs, and the imagination of humankind. Scientifically, volcanoes are also gateways to the secrets of the universe. Scientists study the gases and minerals released from craters to learn about the Earth's inner structure. Some research even suggests that chemical reactions around volcanic vents billions of years ago may have played a role in forming the first molecules of life. This means that volcanoes are not only symbols of destruction, but may also have been the very cradle of life on this planet. But you don't need to travel back to the distant past. Just look at the present. Our Earth is still in constant motion. In Iceland, you can sit in hot springs heated directly by the magma below. In Italy, the city of Naples lives under the shadow of Mount Vesuvius, the volcano that once buried Pompeii. In Indonesia, millions of people live near active volcanoes, accepting the risks because the land there is so fertile. These examples show that, despite the dangers, volcanoes will always have a place in human life. If we look further out into the universe, volcanoes are not unique to Earth. On Mars lies Olympus Mons, a colossal volcano 3 times taller than Everest. On Jupiter's moon Io, massive lava fountains erupt, spewing matter into space. Even on icy moons such as Enceladus of Saturn, we see what are called ice volcanoes, where water and gas erupt instead of lava. This reminds us that volcanism is a universal phenomenon of nature, found everywhere, and may play an important role in creating the conditions for life on other worlds. But beyond all scientific knowledge, volcanoes leave us with a more subtle lesson, the lesson of change. When lava flows down, everything is swept away, but in the end, life returns. It is the endless cycle of destruction and rebirth, and also a metaphor for human life itself. Sometimes we too go through upheavals that seem impossible to recover from. But just like the earth, after the ruins, we can find the strength to begin again. So as you close your eyes tonight, let the image of a volcano guide your imagination. Picture glowing rivers of lava gradually cooling, hardening into rock, and then cracking open to make way for new life. Remember that even in the smallest fissure, a green sprout can still find its path. And in the same way, in the most difficult moments of your life, there is always an opportunity for something new, beautiful, and full of vitality to be born.